All right. As you know, today we're going to start with the trig ratios. If there's time inverse trig ratios, I don't, if not today. At the moment, there's a review, but I may be pushing everything back one class. So I'm going to write a little quick disclaimer. Subject to change is the following. So these two are subject to change, and more than likely, I think I will change. The review will probably be 310. Test probably be just after that, the 14th. So more than likely, this will be updated. And we lost a lot of time. All right, here we go. We're going to begin. So our trigonometry basics. We got three types. So here we go. The first one is the sine, or sin. Basically, it is opposite over hypotenuse. So what you need to do, look at where your angle is located. So the most important thing is, and I'm going to write it, I'm going to write perspective of the angle. Perspective of the angle. That's how we determine sine, cosine, hypotenuse, all that fun stuff. So an idea might be too. You might, listen up everybody, you might want like either a colored pencil or a highlighter, because for instance, the sine of A, you look at where angle A is located. Look at where angle A is located. That's going to help you determine, okay, opposite, you have to look across the way. You have to look. But then the hypotenuse is always going to be across from the right angle. So there's your right angle. There's your hypotenuse. So it's at the perspective of the angle. So you have to look at where your angle is located. Because the sine of B, though, is a little different. Because unlike angle A, angle B is over here. So you have to look at the opposite going this way. So that's what I'm telling everybody. With the sine, along with the cosine, you have to look at the perspective of the angle. Given where the angle is located, that's how you're going to determine your sine, cosines, and all that. So for angle A, the opposite side is across. Now for angle B, angle B, again, look where B is located. To look across. Look across, that's the side. So it all depends on the angle. That's going to help you determine sine, cosine, and all that. But the hypotenuse will always be the same. Hypotenuse is always across on the right angle. So that one, that's a slam dunk. All right, so far, does anybody have any questions? Okay, Valerie, you better put that phone away. Otherwise, it's going to be securities property. I don't know why you're playing with that phone. That phone's not going to help you. All right, so questions about the sine. Again, is that the perspective of the angle? And that's going to be the case for all three. I'm going to copy this because we're going to see this again. But I'll talk about the next thing. Any questions before we go to the next one? So besides the sine, we also had the cosine. Again, it's all about the perspective of the angle. Because you look at angle A, well, of course, the hypotenuse is always going to be the same. That hypotenuse is always across on the right angle. So that never changes. But then cosine of A is the side that touches. That's not the hypotenuse. That's the adjacent side. This is your adjacent side right here. You have to, so the hypotenuse, so it's across on the right angle. The adjacent side is the side that's not that right angle, but that also touches the angle. And with cosine of B, same thing. Look where B is located. This side is going to be your adjacent. And again, side A is your adjacent. And the hypotenuse is always across on the right angle. So what I should have done on the last slide, always indicate your hypotenuse. And then what I would tell everybody is, with adjacent, look at your angle. It all depends on the angle. Label your sides, adjacent or opposite. So I'm going to label this side for the green, and then the blue. This side you're adjacent. This side's opposite. So all depends on the perspective of the angle. But our hypotenuse will always stay the same. Okay, questions? So, and I should have done that with the last one too. Always identify. So look at it, find your angle first, then identify which side is my adjacent, which side is my opposite, which side is a hypotenuse. That's always going to be the case. Identify what's given, what you need to find. Anybody have any questions before we continue? All right. If you want, I can do that to the previous slide real quick. Label. For angle A, there's your opposite. There's your adjacent. That's for angle A. And then for angle B, there's your adjacent. There's your opposite. And then, of course, our hypotenuse is always going to be crossing the right angle. All right. Last thing I want to talk about. Tangent. Again, it's all about the perspective of the angle. Perspective of the angle is going to be the key. Because again, you need to identify. So what? Now in this case, for the tangent, what do we not need to know out of the three? Unlike the other two, unlike the first two, what do we not need? Which is the, yep, so this one you don't need. So unlike before, your hypotenuse, you don't need for the tangent. So for your tangent, so for instance, angle A, look where's the opposite? And you're adjacent to angle A. And then with angle B, it's flip-flop. Angle, that's your adjacent side. That's your opposite. But again, it all depends on the perspective of the angle. Anybody have any questions? Let me finalize attendance. Okay. So now what we're going to do, again, a lot of us need to be arriving here when class begins. I know today was a different story with the bells, but it's still not. You still got to get here on time. Yes, you do. The 7th period. Seventh period after this. All right, any questions before we continue? All right, then the following slide is basically and then in the end, we're going to solve by way of the proportion method, which really, it depends on what's given to you. Because sometimes what's going to happen, and I'm going to show you something on your calculator in a little bit, when dealing with these types of problems, what you're going to have to do, well, this is our general mnemonic, the SOHCAHTOA. I don't know if anybody has heard of this in the past, but the sign is your opposite over hypotenuse. So basically, little equal sign, fraction bar. Same thing. SOHCAH. There's your fraction bar between the A and the H. And then TOA. SOHCAHTOA. The O/H. Now, with these, sine, cosine, and tangent, so depending on what it is, if we're looking for the angle, you just do your division, that's it. But sometimes they might give us a length of a hypotenuse or one of the sides and an angle measure. Then we're going to have to do some flip-flopping. But in the end, that's not bad because it's basically going to be sine over 1, cosine over 1, tangent over 1. That's what we mean by proportion method, especially if you're given only one of the two sides and an angle measure. But again, the key is you have to identify the angle first. Let me see if I can make, no, I can't make that bigger. But yeah, these are the most important rules. Identify your angle first. Locate the three sides with respect to the identified angle. Substitute, solve by way of proportion. And some of these, it may just be just simplify the fraction, yeah, and that's it. But some of them, like the latter half of the period that we today, and what we might do to start our next class, you're going to be given a side angle, and then you have to determine the missing side. And then we're going to have to do something with our calculator. But it's not that bad. All right. Questions before we continue? All right, so here's what we have going on. So the nice thing is with the first problem, the chart is already here. So here's what we got to do first. Determine the sine, cosine, tangent of angle S. So with respect to S, well, first off, let's find where is angle S. You can tell us where angle S is located. In fact, an idea might be, some of you might want highlighters or colored pencils, because this is going to help you. Because right away, what did I tell everybody? The first thing we need to do is what? Look on the previous slide. What was number 1? Okay, everybody, get ready. What was number 1? So just look right above. You don't even have to go anywhere. So you go back to this slide, which is right above. Identify the angle first. That's right. You have to identify the angle. So we have to find, where's angle S? Yeah, where is it? Where's angle S? Is this angle S? There. There's angle S. Well, first you have to identify angle S. That's number 1. Then we need to identify our side. So, well, what's going to be the hypotenuse? The 13 is going to be your hypotenuse. So, bang. That's not hard at all. You got the 13. Now, here's where we need to be careful. Opposite and adjacent. This is going to depend on where your angle is located. So if angle S is here, which side is the opposite? Is it the 5 or the 12? The 5 is the opposite, that's right. Let me do that. I got a better idea. Boom. 5. And then what's the adjacent side? What side's the adjacent? You can tell us. 5's the opposite. That means the adjacent must be, what's our only side left? We got hypotenuse is 13. Opposite 5, the 12. That's it. That's your only option left. 5, 12, and then 13. That's your A. Now, let's do this. Hypotenuse over our sine. So we take the opposite over the hypotenuse. So what's our opposite? What number? Look at angle S. What was the opposite? It's right here. So it's going to look like this. It's going to be, in the end, it's going to be 5 over 13 because it's O over H. 5. Now, you can leave it as a fraction. I'm okay with that. Okay, we should be copying this down. Let's copy this down. All right. And for the second one, what's going to be my fraction? 12 over 13, that's right. And then for the tangent, opposite is, what's our opposite value? It is 5 over, what's the adjacent? Adjacent is 12. Okay, again, part 1, identify your angle. Part 2, identify our sides with respect to the angle. So you identify your angle, identify your sides. And then part 3, this part right here, substitute, solve if necessary. Now these 3 you can leave as a fraction. I'm okay with final answers in fraction or improper fraction. I'm all right with that. All right, so far, any questions? Sorry about that. All right, we'll do another one that's just like this. I want you to try this one. So angle R. So again, where's angle R? Which one's angle R? Corner, bottom, or right? Right side. So angle R is over here. Now, so that's number 1. So then number 2, identify our sides. So you have to identify the opposite, adjacent, and hypotenuse. Well, out of the 3, what's the most obvious one? We can identify right away. We don't, regardless of everything else. 20 is the? Right away. That's the first thing I would identify out of the 3. Now I want somebody to tell me what's the opposite, what's the adjacent.
Opposite would be 12.
Yup, because.
Then the adjacent would be 16.
Yup. Adjacent 16. Opposite Now, do we have enough information to get the sine, the cosine, and the tangent?
Yeah.
All right, I want you all to do that for the next minute or so. Now, you can simplify these fractions. So use fractions, simplify as possible. You can do that. So I want you all to try that for this one. Yeah. If you could simplify, try to simplify if you can. Not the,
The three?
yeah, if you can. Yeah, you might be able to simplify it. All right. Okay. So what do we get for the sine of R? Well, you can give us the original numbers first. Well, what's that? And?
12 and 20.
12 over 20. Now, can 12 over 20 be simplified? Okay, 0.6. That's fine. And then what about fraction-wise? Better try to simplify it if they could. Okay, well, what can we divide both 12 and 20 by? Oh, say again? 3 over 5, yeah. You can divide both 12 and 20 by 4. You can divide 12 by 4, 20 by 4. Okay, what about the second one? What two numbers? 16, 20, which then becomes, what's our fraction? 4 over 5, very good. Some of you put 0.8, okay. I'm not gonna mark it, I can't dock it. Technically, you're not wrong. What about the last one? What two numbers? 12, 16. What was the simplified fraction of 12 over 16? Very good. 3/4. Nice. Somebody put 0.75. It's not wrong. Okay, questions? All right. Now, the next thing, and this is going to be very important. So before you do anything, everybody needs to have a calculator in their hand. If you don't have a calculator, you need to say something. All right. So what you need to do with your calculator. All right, so open up calculators. I need everybody to have a calculator open. Turn it on. What you need to do is hit the mode button. So almost on the top, you see where that blue button, the second button is? There's one called the mode. Hit the mode first. Then you need to go down 2 spots. You know where it says float the radian? I need you to be on the radian. Turn on the calculator. That's what you got to turn on that calculator. That's the only way we're going to get this done. Hit the mode button first. Go to where it says radian. So it's 2 rows down. Then you're going to click one spot to the right where it says degree. I need you to go to the degree. So Jason, go one spot to the right. Then you hit enter. And the degree should be the one that's blinking, not radian. Does everybody have that?
Yep.
Click enter. Hit enter. Okay, that's what we need. We need for it to say degree. So I'm going to come around making sure everybody's calculator is on the right spot. You're good. You're good. You're good. And so hit the mode. All right. Hit clear. Hit the mode button. Degree. Good. Good. All right. So now we're in the right spot. Now our lives are going to be a little easier. All right. Here's what you're going to do. Starting on the next slide, that's going to be important. I'll tell you why. So, here's what's going to happen. You may be given an angle measure and a side, and you're going to have to solve for the variable. But the reason why we need it in degree mode on our calculator is because here's what you're going to do. For the very first, here's actually what you're going to do for all 3 of them. For all 3 of them, what I would do, put a fraction part, put a 1 underneath. That's the very first thing I'm going to ask everybody to do. That's the first thing I'm going to ask everybody to do. So for these problems, put a 1 right underneath. So that's what I'm going to have everybody do right now. That's step 1. Now, step number 2. It says sine of 23, cosine 74, tan of 60. They're actually numbers. Those values are actually numbers. So, for instance, if we turn a calculator on, so if you go, look where the 0 is on the very bottom. You're going to go up 1, 2, 3, 4, 5, where it says sine. Everybody see where it says sine, S-I-N? Touch that key first. Then, touch it once. Type in the number, 23. Close parentheses. Then hit enter. See what you get. That's fine. What is that decimal value?
0.390.
All right. Okay. So, what? Okay. I'll type, all right. On your calculator. Did you find the sign button on your calculator? Did you type in 23? Yeah. What number did you get? 0.03 what? Hold on, let's come out. Start again. No, okay. Clear everything. Hit the sign button. Type in 23. Close parentheses. Open now. Now hit enter. That's the number you were supposed to get. So in the end, the sign for 23 is supposed to be. Oh, that's not working here. That's all right. That's supposed to be. Okay, I'll write it in. It's supposed to be what? 0.3907. 0.3907.
07.
You don't have to go beyond here. Over 1 equals x over 15. Okay, now, can we solve this like a proportion? You can. Well, what's 1 times x? X, so in the end, 1 times x is just x. And then, what are we going to multiply? What two numbers?
0.3907.
0.3907 times 15. Sorry, it's going to be a little combobulated here. I don't know why So you're going to multiply those two numbers. All right. Multiply those two numbers. What do you get? 0.3907 by 15. All right, so about 5.86, 5.861, that's fine. But then, yeah, you multiply these two numbers, x is going to be, I'm going to write the final answer. I don't know if it's going to show up in red, but we'll try it. 5.86.
Yeah, 5.86.
All right. I'm just going to stop. I'm going to just write 5.86, if that's okay. And we should do like an approximate. So rather than equal sign, it might be approximate. So yeah, in the end, the sine of whatever, the cosine of whatever, the tangent of whatever, it's just going to be an actual decimal or value. All right, questions on the first part. And again, we know how to solve for proportions at this point, right? Okay, what about the second one? If we do, what's the first thing we need to do right away with a cosine of 74? What do we have to do? Okay, so let's figure it out. What is that number?
74.
Well, cosine of 74. It's going to turn into a decimal. Who can tell us what that decimal value is going to be?
0.2756.
0.2756. All right. It's going to be point. Point 2756. All right, now, to get W, what's the only thing we have to do to this problem? Because, of course, what's 1 times W?
W.
W. So basically, if we want to figure this out, what's the only thing we really have to do?
Decimal number times 5.
So it's 5 times that 0.2756.
That's like 1.37.
Mm-hmm. So in the end, you're just doing it cross multiplying. So it's going to be 5 times, and I'm going to put this one in parentheses. 0.2756. And then as Catherine said, it was about what number again?
1.37.
Okay, 1.378, 1.37. I don't know. All right. So, questions on that problem? Okay. What about this last one here? What do we have to do to the tangent of 60?
Tan 60.
You get one number.
Get 1.73.
Okay. Oh, yeah, this is going to be a funny one. So tangent of 60. That becomes 1.7. We'll say 3. Yeah. 2 over 1. Now, what you could do, anytime you have something like this, what you can do, can we switch the y into 1.732? Can we put the y here and a 1.732 on the bottom? You can. Yeah, because what's going to happen when you do your diagonal multiplication, I'm going to type this out. So what's going to happen, you're going to have, well, what's 3 times 1?
3.
3 times 1 is 3. But then you're going to multiply by the 1.732 times the y. Let me see if I can move that over a little bit and make that smaller. But then what do you really have to do in the end to get the y by itself? If we want y by itself, what do we have to do to both sides of the equation?
Divide by 1.
Not divide by 1, but divide by?
3.
Nope. Got to divide both sides by the 1.732 because here's your variable right here. Our goal is to get this one by itself. Now, when you divide the two numbers, so when you had 3 times 1, do we really need the 3 times 1? No. So it's just 3. But now we're going to divide both sides by 1.732. Now be careful. Look what you get. Look what happens when you divide 3 by 1.732.
It's like 1.732.
Yep. As it turns out, yeah, it's actually going to be divide this, you divide by that, you're basically getting the same number right back. Yeah, you're getting approximately the same value right back. So don't be surprised. All right. I think at this point, I think at this point we're going to stop for today. Being we only have about 3 minutes left in the period.